Check. All right, we're on now. All right, good. All right, so we're on, but we have one other issue. And that one issue, we are not using our stream name. And that is going to create some problem. All right, just let me just get out of the way, guys, if you can hear me. I think we're on live now. You should be able to hear me. All right, can you hear me, guys? Not seen. Can you hear me now? All right. It seems as if we can hear. All right, I'm just fixing the back end so that everyone can reach me. Just give me a second here. All right, very good. So I'll be on in a bit. Just give me 1 second. I'm sort of do some logistic work in the back. I'm not too sure what happened. We tried a couple of different headsets and it just wasn't working. I tell you sometimes things like these happen, but we'll be fine. Trust me, we'll be fine. All right, so I am just sorting out the back end here. And then I will be there with you guys doing as was planned. I can't shut down the live that was before. So I might as well just name this 26. All right, so we are, sorry, man, everything is just not working well. I'm going to rename the show for 26, Excretion Volume 26. I think my face should be there. All right. So a lot of persons were shocked just now. We are back on. I am very, very sorry for whatever happened. I really don't know what happened. But every now and then technology will cause will have a little hiccup. Good evening and welcome to CSEC Biology HSB Live. Of course, it is CSEC Biology, the cover page. And I am Mr. Wilson and we're streaming out of Kingston, Jamaica. And we hope that wherever in the world you are doing well. I want to say a big thank you to all members of the family who have been working with us since even we've been having a little challenge and are some challenges. And of course, they have been with us all evening. We're going to be having the show as usual. I approach the show, I like to say, with the thought that, of course, not all trees in the forest will pretty much grow at the same speed. And so too, not all students will learn pretty much at the same rate. I also believe that for those students, our children, who are from a loving home, they will also be able to see the top of the mountain as they'll be able to stand on the shoulder of members of the family. Good evening, Amoy. Good evening, Gray. Good evening, Jawawan. And I'm waiting on the other members of the family. But if not, of course, you know, you could hit the replay. The video will be here. We're going to be doing excretion. And like I started out by saying, excretion is so much of a wonderful topic. One of those topics that you have to cover whether you're doing biology or you're doing HSB. The fun part of it this evening is that we've covered it for both biology and HSB. It would be nice if you have a textbook because when we're looking at a diagram of the skin, we want you to be able to follow as we go through the skin and of course make some explanations. Some things you might know, some things you might not know. All right, I'm seeing minors, I'm seeing, of course, new persons. Good night, good evening from wherever you are in the world. So I want to hit off the show. We're talking about excretion. And let me just remind us that excretion is pretty much a process of removing metabolic waste from the body. What it means is that these were actually, the waste that is removed was actually produced, or they are actually product of the cell. So once we talk about metabolism, or talk about excretion, it is of course something that was made in the body that of course is being removed. Now, it's very important to note as well that feces is not an excretory product. Let me say that again. Feces is not an excretory product. And I'll explain why feces is not an excretory product. As we said before, in order to be classified as an excretory product, it must be a product of metabolism, which means that it was made in the body. All right? Or it is as a result of some reaction that is taking place in the body. So one might ask, then what is feces? You want to tell me in the chat there, what is feces? It's not an excretory product. It's not a secreted product. So what is feces? Let me know in the chat there if you know what is feces. It is not an excretory product. Good evening, good evening, good evening. What is feces? That's a big question this evening. All right. As you roll out, I have to tell you, and I have to roll right along. Now, feces is what we refer to as an ingested product. You would have recalled when we spoke about holozoic nutrition. Feces, when you get to the exam, please be reminded that feces is an ingested product since it was not made during metabolism. So feces is not made in the body. Strange thing. Why would Mr. Wilson say that? Feces is actually undigested food, not absorbed by the body. So we talk about undigested food. If you were in the army, they would have fed you on a ration. And they're feeding you on a ration that you don't have too much waste food, or you don't give the body too much work. So what happens is if you eat too much food and the body doesn't need all that food, what will happen is that some of the food will just pass through the system pretty much as refuse, but as it is going through the system, it is going to pick up waste material. So feces is not an excretory product, but feces does contain excretory product. So what are some of the excretory products that we can find in feces? Now, some of the excretory product would be like bile. You remember bile from the liver. Mucus, those are made in the body. Salts, and of course, enzymes. Be reminded that an enzyme, I hate to say that type of thing with enzyme, but enzymes are chemical. They are not organism. They cannot be killed because at no point they were alive. So when we're talking about enzyme here, just let me put this bit here in. When we're talking about enzyme, the only thing we can say about enzyme is that enzymes can be natured. Now, from wherever you are in the world, please be reminded that you should like, share, and of course, if you like the show, subscribe. Now, what is the importance of excretion? We're talking about excretion, ejection, that type of thing. Excretion is important in order to remove metabolic waste, which, if not removed from the body, could poison the cells. Simple. It must be removed in a timely manner. And there are many products that are excreted. And when we're talking about excretion, let us not limit ourselves to the concept of excretion in animal only, because plants do excrete as well. Good evening, all. All right. So we're going to be looking very quickly at the main organs and products of excretion in human. Anybody want to ask me anything about feces before I get there? Anything you want to ask? All right, no. So I am going to be asking you some questions. Can you name me 4 organs that are directly associated with excretion? Very quickly. 4 organs that are directly associated with excretion. Very quickly. Very quickly. So we have one of that organ there that is responsible for. All right. So we're seeing. All right. So Jawa is saying the lungs, the kidney. All right. Gray is saying the kidney. What else? 4. That's just 2. The skin. The skin. All right. Very good. The liver, the kidney, the stomach. The stomach is strange to me. I've never seen that. I would ask about that, but for now, I'm not going to be accepting that. But you could tell me more about it. But I have never seen the stomach being this organ for excretion, but I have seen the stomach being an organ for secretion. You see, there are 3 words that we're working with. You know, we have to be very careful how we play with them. We're working with excretion, we're working with egestion, and we're also working with secretion. But now we're talking about excretion. So the alimentary canal, very good. Oh, you're guessing. All right, that's fine. That's fine. That's fine. Beautiful. I like when you say you're guessing. All right, kidney. All right, lungs, skin, alimentary canal. All right, beautiful. Those were well said. Look at what Amoy has, and I think a couple of other persons would have bits and pieces of the main organs of excretion. Of course, the liver, if you use the liver is used interchangeably with the alimentary canal. All right. So when you say liver, you might see in some book liver. In other books, you might see the alimentary canal. Beautiful. I think you did well. You need to give yourself a round of applause. Awesome. You did wonderful just now. Now, what we want to look at is what are the products that are associated with these organs. But hold one bit. I want you to give me these products linking to the organ that I am going to ask for. I'm going to be asking for the organ, and then you are going to tell me what is excreted or what excreta is associated with this organ. We're going to start with the lungs. What are the products here? What are the products being excreted by the lungs? What's associated with the lungs that's excreted? All right, let me see what's happening here. All right, so good evening to everyone from wherever you are in the world. Please be reminded to like, share, and of course, subscribe. And if you have not yet joined the show, it's time to join the show. You just need to have a YouTube account. Come on over, and you can be a part of a live chat. We're having power classes here, so we're trying to complete a topic per class so that we can have time to do more practice for exam. So let me see what's happening here. So Jawaran is saying carbon dioxide, water, vapor. I was expecting carbon dioxide and water, vapor. Carbon dioxide, let's go, let's go. I'm still looking for something else. Jawaran, you're right. Bertram, you're also correct. But I'm still looking for at least 3 things that comes up. All right, carbon dioxide, carbon dioxide. Very good. Hi, Tanisha, how are you? Amoy, from the lungs, excretory products, carbon dioxide, water vapor. I am expecting that, but I need another, just one more. Just one more. I'm seeing carbon dioxide, I'm seeing water, but I'm waiting for one more. No, not mucus, not mucus. Mucus is a secretion in the nostril, right? And it depends on when. All right. So we're going to talk about that. No, it's not nitrogen. I'm talking about heat. All right. If you feel it, you'll feel hot here coming out. So of course you're losing heat as the air is of course excreted. And the major thing that we're getting rid of here, you observe that I said air, but in the air we are also getting rid of carbon dioxide, water, and heat. And the carbon dioxide here is associated with animals. But when we get over to plant, we're going to see that both carbon dioxide and oxygen are excretory products. Remember, for excretion, it must be made in the body. And here we can see that carbon dioxide and water and heat, they were made as a result of respiration. Go to the formula for respiration and you will see. So the carbon dioxide is coming from respiration. The water coming from respiration. The heat coming from respiration. So of course, it was made in the body. So now we move on to the skin. Beautiful organ it is. It's called the integument system. So we talk about the skeletal system, the nervous system, the reproductive system. Now we're talking about the integument system. So the skin is pretty much the largest organ the body has. So now we want to know what are the products that are excreted by the skin, or the products that are associated with the skin that are excreted. What are those? And they come out in the form of sweat, right? So tell me what is excreted. So from the skin, we have water, salt, traces of urea. Water, salt, and of course, small amount of urea. Salts, water, and urea, salt. All right, try to give everything, I mean, you're going to be at its spot on. You don't know which one you're going to need for the exam. So just try to practice with all. Try to practice with all. And don't just do the exam and say, oh, from the skin I get sweat. No, break it down. What is it that the sweat contains? The sweat will contain water, salt, and traces of urea, and urea is organic, and it is a nitrogenous, that type of thing. You need to know it. All right, I'm shaking, and it might be dancing your high. All right, so we're going to be looking now at the alimentary canal / liver. What are the products that are excreted here? All right, what is excreted by the alimentary canal? All right, the first thing we can think about bile coming from the liver. Yes, then we can talk about water. All right, and that would be something coming from respiration. We can think about the salt and think about deamination, and we have urea. All right, very good. So from the liver, urea, it might have a small amount, but bile, water, salts, mucus, urea, liver. You might have a little trace, yes, bile, but the big thing here is going to be the liver, bile, water, mucus, salt. Those are going to be the big thing. For urea, nitrogenous waste, yeah, you might have some, but it's not a biggie. It's not a biggie. All right, so we have a little bile salt, trace of other substances, while which are passed out in, of course, the feces. All right, that's true as well. All right. Bertram, you are not on the right path. Remember, we said that feces is not T-O-N, not. All right. Remember, we said that feces is not an excretory product. Feces is an ingested product. And we also explained that feces is not an excretory product because it has not passed through metabolism. And we're saying once it would have passed through metabolism, it means that it was made in the body. Like we spoke about the water, the carbon dioxide, the heat, which are very, very easy to explain and to remember. Those are made as a result of respiration. All right, so please let us be reminded. Feces is not a product of excretion. It's not an excretory material. However, it contains excretory material, right? So we could say that a bus is not the seat, but the bus has seat in it, all right? That type of thing. The bus is not the seat, but within the bus, you are going to have some seats. All right, so that type of a thing we want to remember. And then we get on down to the kidney. What is it that the kidney is getting rid of? The kidney, a very, very important organ. If you have ever seen a renal patient, you'd understand how important the kidney is. The kidney, what is it that we're getting rid of? All right, urea. Anything else? Urea. Anything else? Kidney. All right, so we're getting rid of urea, salt, water. Urea, salt, water. Now, the key thing to remember here, if you are going to be locking onto excretion, is that these things were made in the body. So for the kidney, you have, it's coming off as urine. All right. Of course, the alimentary canal is going to come out as feces, but feces is not the excretory product. And the same thing we have for the skin, it's going to come off of sweat, but sweat contains some stuff, and then we have expired here. So we want to ensure that we have all these stuff well laid out in our head. So feces is not the excretory product, however, it contains excretory product, and we made a list of those. Very good. I think you guys are doing well. I think we are going a little faster than I actually expected us to, but that is wonderful. Now, that was a whole lot for both biology and HSB. Most of what I'm going to be doing on this page now is for the bio student. We're going to be looking now at the main products and organs of excretion in plants. Everybody can tell the name of an animal. Very few persons know a plant. Very few persons. All right, yeah, the youngest again. So let us go. All right, so we're looking now at a plant. And the nice part of how I wrote the lesson is that just the last class we had on Sunday, we're talking about photorespiration and that type of thing, when the plant gives off oxygen versus when the plant gives off carbon dioxide, that type of a thing. So I'm going to start you off with that. What are some of the waste products given off by plants? What are some of the products given off of excretory product from plants? All right, so I'm looking at the chat there. What are some of the products? So we have water, transpiration process. So water is given off. All right, what else? What else? What else is given off? Oxygen is given off. Yes, that is from the process of photosynthesis. What else is given off? Water is given off. Yes. Oxygen is given off. What else is given off? What else is given off? Come on, guys. Come on, guys. Come on, guys. The plant just can't live without that. All right. So carbon dioxide is given off. Beautiful. So during the day, the plant will be giving off oxygen as a result of photosynthesis. During the night, the plant will be giving off carbon dioxide and water as a result of respiration. Let us remember that. So let's go back to it again. So during the day, the plant is giving off oxygen as a result of photosynthesis. And we looked at that when we looked at photorespiration in the last class. During the night, the plant is giving off carbon dioxide and water as a result of respiration. Now, the big question here pretty much is, what are those plant organs, the parts of a plant that are associated with the excretion of this product? So we could talk about, let me just start off by talking about probably two, and then you are going to tell me the other one. Are you telling me the other one and I tell you the other two? Whichever one. So I want you to tell me what part is responsible, what organ is responsible for getting rid of, somebody says stomata, but where do we find the stomata? That's a nice, fancy, pretty word. Where do we find the stomata? I'm searching. Where do we find the stomata? Can somebody tell me? Where do we find the stomata? Hey, we want to get some oxygen, some carbon dioxide out of the plant. Hey, where can we walk? Oh, yes, it is the leaf. It is the leaf. So the stomata are some tiny holes in the bottom of, they're concentrated in the bottom of a leaf. And through these tiny holes in the plant called stomata, you are going to have oxygen diffusing out. Remember when? Carbon dioxide diffusing out. Remember when? Water also coming out through these pores. And remember, it is very important. So I'm seeing a nice word there now. Other than the leaf, I'm seeing a nice word, the lenticels. All right. So the lenticels and the bark of the tree and the root, these are going to be other areas that are responsible for excretion. And we're talking about three things here now. We're talking about oxygen, carbon dioxide, and water. And the part of a plant that is associated with these is going to be the leaf, the lenticel, in the root, and the bark of a plant. Is a pore found in the epidermis or leaf stem and other organs? Newman, what are you? I'm not too sure where you're going with that, Newman. See if you can give me a better explanation, please. All right. So as we wait on that explanation, there are some other words that are not so fancy and so familiar to a lot of persons. But of course, the plant continued to carry out excretion. Cells a plant continues to carry out excretion. And I'm going to be telling you about some, and then I'm going to get back to the technical stuff. We all would have seen a leaf change into yellow. I'm very sorry. We all would have seen a leaf changing to yellow and then fall off. If that were to be a leaf that is from a mangrove plant, if that were to be a leaf from a mangrove plant and you were supposed to taste the latex there, it would have been salt if, of course, the plant was pretty much in a saline environment. Then there are some leguminous plants and other plants that you'll see sap flowing out, like we call it stain flowing out. Those are ways in which plants get rid of waste. So we are going to look at some of the products that the plant would need to get rid of. Excretory products are lost when leaf fall off. Very good. All right. So we're going to get rid of tannins, anthocyanins, alkaloids, and calcium oxalate. So tannins, anthocyanins, alkaloids, and calcium oxalate. Now you want to ensure that you know these by your students, right? Anthocyanins, tannins, alkaloids, calcium oxalate. And the plant get rid of these through leaf, bark, petal, fruit, and of course, seed. Now, it's very important that we remember that the plant stores some of these as oil and what we refer to as insoluble crystals. Example, calcium oxalate crystal. So the plant will store some to get rid of it later. But because it is insoluble, what we mean when we say insoluble, it is not able to dissolve. Right? So because it's insoluble, the plant tends to store some in the leaf, in the bark, in the petal, in the fruit, in the seed, in order to get rid of it. You'd agree with me that not all seeds are edible. And there are even some seeds that are edible, but not everyone can eat it, like peanut. Not everyone can eat peanut. It might be too toxic for some person. Body just can't deal with it. So those are some things that we need to recall for biology with plants. This here, biology with plants. Now, insoluble form does not affect the plant and are, of course, stored in the named organs I mentioned just now until they shed or fall off. And of course, they're going to fall off, like the leaf will fall off as being a yellow leaf. And of course, to talk about excess stain that we spoke about earlier. And of course, the plant, you'll see some plant, the bark is coming off and all of that. These are ways in which a plant is, of course, getting rid of the waste. So we spoke about the waste itself. And then we spoke about how the plant is getting rid of the waste. As we spoke about it in animals, when we said that as with the alimentary canal, it is the feces that is carrying it out, right? And we spoke about the skin, the sweat is carrying it out. And we did all that example as we look. The same thing here for the plant. Though we have these excretory product, we must have a way to get rid of them. All right? Good. There are persons with allergies. Very good, very good, very good. All right, so now we're going to be moving on to something new. We covered products that are being excreted by both plants and animals. Now we're going to be looking at the excretory system. If you don't know the system, like from the top of your head, you probably need to just pull out your textbook now and, of course, follow me as we go through the system. I'm going to try to find some easy way for you to remember the parts of the excretory system, of the kidney, that type of a thing, because we're going to be going through the excretory system, we're going to be going through the kidney, we're going to be going through the nephron. All right, so you want to ensure that you have your textbook so we can go through and you will follow nicely. And of course, when you get to that exam, you'll be comfortable. All right, so good. So let us look at the excretory system, as we call it, and it contains pretty much two kidneys. And what we like to say is that the kidneys, there are bean-shaped organs, and you have one on the left and one on the right. When you get to the exam, what CXC is asking for is not just a label. All right? It's not just a label. CXC saying that you should label and annotate. Label and annotate. And remember that annotation is just a short little writing about whatever part you're writing. It might be a description, it might pretty much be a function. All right? And being that I'm talking about labeling and annotation, just let me just pause and talk a little bit about drawing. If you have not gone to my channel to look at the video on drawing skill, you need to do so once you're doing biology and you are integrated science or chemistry or physics. You need to go there to look at the rules that, of course, govern drawing. All right, I have it on the skill. If you go to my channel, you see it on the skill in the playlist. That is something different than lab reports. All right, I'll wait on the spike to pass and then we go again. All right, good. So I said that we have two kidneys, and in some cases, you might find three in some persons, and we're going to be talking about that. All right, so there's a kidney on the left, and there is a kidney on the right. But why is it even important to talk about a left kidney and a right kidney if we're saying that we have bilateral symmetry, meaning that the left side look exactly like the right? Is that always true? Definitely not so, because we have seen in the art where the left ventricle, the walls was much thicker than the right ventricle. Now we're looking at, of course, the kidneys. Now look at what happens here. The left kidney is slightly higher than the right kidney. So if they were both here, then what you'd find is that the left would be a little higher than the right kidney. So if you were to be a doctor and you were, let me hope that you're not that type of doctor who was drinking, now you were looking at somebody on that table, and of course you're not too sure which one is the left and which one is the right. You could definitely look for which kidney is the highest, and the highest kidney is going to be the left kidney. All right, you want to ensure that you do that. Remember, when we talk about left and right in biology, as it were, with a patient, your right is going to be the patient left, because the patient is lying down on his or her back. So that is only natural. All right, and that is how we easily identify. And it's the same thing as if you were looking at a piece of paper with Mr. Wilson drawn on the paper. Your right would be Mr. Wilson's left. All right, good evening, all. All right, so now we are going to get into the system, and we're going to go through the system very, very quickly. So we spoke about the right kidney and the left kidney. Now we're going to be talking about the aorta. What type of blood does the aorta take to the kidney? Oxygenated or deoxygenated? Tell me in the chat there very quickly. What type of blood does the aorta, it's going to take it down to the renal artery, and it's going to get into the kidney there. Now, what type of blood it is? Is it oxygenated or deoxygenated? And that's question number one. Question number two is coming shortly. Type in the chat there for me. We're taking blood now to the kidney, and we're coming down from the aorta, and of course, we're going to be popping on into the kidney with the renal artery. But we want to know what type of blood is going to the kidney. Is it oxygenated or deoxygenated? Okay, good. The question is, we have some blood coming from the aorta, and it's traveling pretty much on its way to the kidney. So it's going to come down the aorta, then it's going to go into the renal artery, and then it's going to up on into the kidney. Now we want to know, is this oxygenated blood or deoxygenated blood? All right, Robertson says oxygenated. Blue one says oxygenated. Any other response? Come on, guys, I want everybody to respond, you know. All right, oxygenated, and even if you guess, if it's a guess and you just tell me that you're guessing, all right? So we want everybody to respond because we want to be able to ensure that we're planning the lesson so that we can reach everyone. And the examples that we use will, of course, reach everyone. So please respond. All right, so oxygenated, beautiful. So oxygenated it is. Oxygenated it is. Now I'm going to ask you a second question, and I'm like driving home the point. Some persons like to talk about dirty blood or clean blood. That I don't know if you understand the concept of dirty blood. But we're talking about, when we talk about dirty blood here, we'll be talking about blood going to the kidney that needs some cleaning up, right? We want to remove some waste product from it. So the blood that is going to the kidney, using my analogy, please don't write that on your paper. Is it blood that has things to be removed? Is the artery carrying blood to the kidney with things to be removed? Or is it going to the kidney to pick up stuff? The blood going to the kidney from the renal artery, is it blood to be cleansed or is it already cleansed? Tell me in the chat there. The blood going to the kidney, is it blood going there from the renal artery to be cleaned? It is going to the kidney to pick up stuff. Interesting. Hold on a bit. Interesting. It is blood to be cleaned. All right, blood to be cleaned. Anybody else? We want to know if the blood going to the kidney, if it is going there to be cleaned. All right, so it's Tinisha is saying that it's going there to remove stuff. All right, unwanted stuff. All right, beautiful. A lot of things have been said here. All right, so Newman, you will have to revise your answer. Please see if you can just revise, check your book and see what's a real thing there. Anybody else want to try this one to be cleaned? Anybody else want to try this one? I know that the topics are getting a little tough on you as we go deeper into the syllabus. All right, so the answer here is that it is going to the kidney to be cleaned. All right, the blood going to the kidney, though it is oxygenated blood, it has stuff in it to be removed. And we're going to prove that to you as we go through the excretory system, then the kidney, and then the, of course, nephron, or what we call the kidney tubule. I don't understand what that means. Who am I answering? All right, beautiful, beautiful. That's fine. That's fine. That's fine. All right, so let's backtrack a little bit. When we spoke about the kidney, we said that there are some products that are excreted by the kidney. Bertram, can you recall these products that we said that are supposed to be excreted from the kidney supposed to take care of? You remember them? All right, anybody remember can tell her what are some of the things that the kidney is expected to remove from the blood? Anybody can tell her? I'm listening. I really don't want to say it. I want to see how much we're learning. All right, tell Bertram for me, what are the products that are removed from the blood by the kidney? What's that mean? So there are other persons who don't understand? Really? All right, so just now, all right, so water and salts are products that are, of course, removed from the blood. Urea as well. Now, we're trying to help Bertram here. She said that she doesn't understand. The question where we started out, I was asking the class, the blood going to the kidney, Is it blood that need to be cleaned up to remove stuff from, like water, salts, and urea? Right? Most persons say yes, it is blood to be cleaned up, right? Not carbon dioxide. All right? Hold on, don't go too fast. Don't go too fast with the glucose stuff. Let us not go there as yet. All right. So we were asking, is it blood to be cleaned? Because we already established that it is oxygenated blood. But while it is oxygenated blood, it contains urea and salts and water and all of that needs to be removed. And we soon talk about the fine tune of removing it when we talk about ultra filtration and selective reabsorption. We soon talk about that. All right. So we agree that the blood that is going to the kidney, it is not just going to the kidney to pass through the kidney. That blood that comes down the aorta and go to the renal artery and gets into the kidney, it is going into the kidney to, of course, be cleaned. And we're going to talk about what cleaning means as we go deeper into the lesson. I do hope that you are understanding a little better now, Bertram. All right, but Bertram, very good. Water, salts, and urea. So pretty much we're just asking when it gets to the kidney, what happens? That's another way to ask the question. Rather than to ask if it's been cleaned, we could ask about that, but we chose not to because we wanted to understand if you understand exactly what we're saying here. All right, very good. So another thing we could talk about is that the the renal vein, is now going to take clean blood that the water and the salt and the amount of water that needs to be removed, not just all the water. The renal vein is now going to take this clean blood, or what we call a purified blood, from the kidney. So if I were to say, layman terms, the renal artery is carrying in dirty blood into the kidney that has things to be removed. And then the renal vein is taking this blood that having been cleaned up in the kidney from the kidney, and then it is going to now take it back to the vena cava. Are you with me? But while all this happens, and this is just a summary of what happens, because when we get into the kidney, you understand a little better. While all this happens, and we have the selective reabsorption and ultrafiltration and all of that taking place, then there is the remains that is left behind that is collected in the collecting duct, right? And then gets to the pelvis, and then it gets into the ureter. All right. So the ureter, I think it has how many letters? How many letters do we have in the word ureter? Anybody can count them and tell me? How many letters? Ureter. How many letters do we have in the ureter? Ureter. You know that vessel coming from the kidney down to the bladder? How many letters do we have? Tell me in the chat there. Tell me in the chat. I want to know. Oh, wow, wow, wow. Everybody's spelling very, very well. We have 6 letters. Oh, beautiful. That's awesome. All right. So now that we know how many letters, somebody said 7. No, you can't say 7. It must be 6. Spell ureter in the chat for me. Somebody spell ureter for me, please. Ureter, ureter. 6 letters. Hold on. Pause one bit. Now I want somebody to tell me how many letters we have in urethra. Yeah, come on, tell me. How many letters do we have in urethra? So we're finished with ureter for now, and we want to look at 7. Tanisha said 7. Anybody else? How many letters do we have? How many letters do we have in urethra? Urethra? 7. Shakila, you need to go back to that word. Go back to your text. How many letters do we have? 7. Anybody else? 7. Anybody else? Urethra. So let us count those now. Tanisha has spelled the word for us. Is it 7? It looks like 7 to me. It looks like 7 to me. Beautiful. Now, the other question I'm going to ask you, when you are counting, what comes first, 7 or 6? When you are counting, what comes first, 7 or 6? When you're counting, what comes first, 7 or 6? I don't know. I can't count so well. That's what I'm asking you. All right, beautiful. So if 6 comes before 7, there is no need to be confused about ureter and urethra. There is no need to be confused. So after today's lesson, you will always recall that ureter with 6 letters comes before urethra. So the urethra is the one coming from the kidney, and you started looking at the diagram from the top coming down, and that is why I had urethra. Then we got into the bladder, right? And then we went through that sphincter, the sphincter muscle, and then we came down to, of course, the urethra. And if you have a penis, it is the urethra that goes through the penis, that opening there, that allow you to expel urine. So if you want to come from below, then it's going to be 7 letters. If you're coming from top, it's going to be 6 letters first. But no student should go to the exam and be confused about which one is the ureter and which one is the urethra. Now let's talk about the bladder. So the ureter is going to, I like that differentiation. Beautiful. All right. Let me see what's happening here. Urethra tube carrying, very good. Urethra tube. All right, very good. All right, so the ureter is taking blood to the bladder. I don't remember here. Is it taking it to the gallbladder? Is the ureter taking the urine to the gallbladder? Tell me in the chat. Is the ureter taking the urine to the gallbladder? I don't know. Tell me in the chat. Is it taking the urine to the gallbladder? Oh no. Oh, it's taking it to the urinary bladder. Oh, where is the gallbladder? Where is the gallbladder? Where is the gallbladder? I'm confused. Where is the gallbladder? Can somebody help me out here? I'm all confused and I'm confusing you all. Where is the gallbladder? Oh, yeah! The gallbladder is in the liver. And when you remember the gall, G, you remember green because it's associated with bile. Don't tell anyone I told you, but the gallbladder is associated with bile, green. So the ureter has nothing to do with the gallbladder. It is the urinary bladder. Don't mix them up, all right? So so the ureter is taking urine to the urinary bladder. Beautiful. And it has a muscular makeup and it stores urine. So as it stores this urine, at the bottom of the bladder, there is what we refer to as a sphincter muscle, which contract and close. It closes the bladder, thus preventing urine from spilling. Urine really doesn't have a wonderful scent. Can you imagine if that sphincter muscle is not working? We're going to get there. So as the urine fills up the bladder, the weight on the sphincter muscle tells you that you want to pass your urine. This is not something that babies can control. They can't control the sphincter muscle. It is something that grown adults, in most cases, can control. However, I've not seen this on the syllabus, but I'm sure that you should know. However, there are cases where the sphincter muscle become weakened or defective. And it could become weakened or defective for more than one reason. One, you could have an infection of the bladder. And when you have an infection of the bladder, because of this irritation, uncomfortable feeling, then you want to go very often. And in some urinary incontinence, I can't even breathe to call the word. But if you have a stroke, yes, put by the word. It's a good word. It's a good word. Don't do that. Don't remove the word. Don't follow me. Don't follow my games. Don't follow. Put by the word. Urinary incon. I can't call the word. But if you have strokes, you are affected by that. What it means is that you can't hold your urine. All right. Incontinence. Urinary incontinence. So what it means is that, like I said, you are not able to hold your urine. But don't follow me with my all sort of games. All right. And of course, if you have an infection, it will not allow you to, of course, keep that urine as long as you would have. You're going to want to go very often. And in some cases, you are going to trickle after you go. And if you trickle after you go, in some cases, I am a biology teacher, so forgive me, I'm going to be talking some stuff. If you trickle as you go, in some cases, you will have to wear a shield if you're a woman. And of course, if you're a man, then you will definitely have to wipe. And if you are not wiping, if whether you're wiping or wearing a shield, it is very important that you see the doctor. All right. So outside of infections, age could also cause the sphincter to become weak. And if age causes the sphincter to become weak, what will naturally happen is that you're going to be having spillage. So it means that you'll have to bathe more often, you'll have to change your clothes more often. And if you are troubled with things like that prostate problem thingy, you might have problem holding your urine as well. So don't take it for granted that to pass my urine, duh, I can do anything. You have to also practice proper hygiene and, of course, probably monogamy. All right. Choosing sex partner and all of those things are very, very important with protecting this part of your body. And I needed to say all that. So forgive me if I held you there a little long. I needed to do that because I really don't want persons to leave here and not knowing that the bladder is this special place that if you play around, you might lose it. And if you play around and the infection gets so bad, it could even damage the kidney. We don't want to go there as yet. We're going to go there later in the show. All right, beautiful. So we have been talking about the excretory system, and we made mention of a lot of things. We made mention of the aorta, we made mention of the vena cava, we made mention of the renal artery, we made mention of the renal vein, we made mention of the urethra, we made mention of the urinary bladder, we made mention of the urethra, we made mention of the sphincter muscle, and a lot of persons would have come up on the new word, urinary incontinence. Urinary incontinence. All right? You can go slow like that and you'll be able to pronounce it. If it's a new word for you, you might have a little problem pronouncing it, but if you go a little slower, it will be good. All right, so somebody's saying here, Tanisha, surgery. What was surgery again? Surgeries could, of course, cause you to have that problem. When you have a prostate thing and you go and do something, something, of course, you come back, you might have problem holding the urine. That could be a problem as well. All right, good. I hope I haven't lost anyone. We went through the excretory system, and the excretory system is pretty much a summary of what actually happens. Now we're going to get a little deeper into the matter. We're going to go inside of that kidney now and dissect it, and of course talk about some nice stuff. And then we're going to probably have a little more appreciation for the work that the kidney does. So the first thing we want to talk about, what is the real function of the kidney? Tell me in the chat there, what's the function of the kidney? What the kidney does? Because we're talking about excretion and kidney plays such a big role. What is it that what's the function of the kidney? Drop it in the chat there for me, and I wait on that there for us to move on while they drop it in the chat. It filter blood. Give me something better than that, Tanisha. Lick it the nail right on the head. Don't go around like that. Tell me exactly what it does. More than yes, it filters blood. Yeah, but give me something better than that. Tanisha, come. More than that. All right. So the kidney, we said earlier, is a, I'm waiting for the answer now, is a bean-shaped organ. Or it's shaped something like a piece, you know, that red piece for Sunday. And you see that little scar that you have there? Pretty much the kidney is like that, and that is where the scar is pretty much where you'd find the blood vessel and the urethra coming out. All right. So, oh, let me see. A lot of things been said here. Well, the function of the kidney here is to get rid of toxins. That sounds a little sweeter to me. All right. Get rid of excess water. That is another sweet thing there being said. All right. It take unwanted substances from the blood and let them pass through the bladder to be excreted. Boo, let me tell you something. That definition says a lot to a person who understands. But for students, we try not to have our students write like that because it's pretty vague and pretty much doesn't say all that you want. You want it to be hit. We want you to hit it on the head as Jawawan did just now. She spoke about get rid of toxins. So we're sure of that the kidney is doing that. And when you leave here, you can say, well, the kidney get rid of toxins. You can also say that the kidney get rid of excess water. You know exactly what you're talking about. And that is what we want. So even if you would have said what you've said just now, boo, we want you to get to the point where you can see it exactly like Jawawan said it just now. Let me see what Mila is saying. Function of the kidney is to remove waste product and excess fluid from the body. These waste product and excess fluid are removed through the urine. All right, Mila is saying a lot there, but we're afraid of these type of definitions because what it does, it allows the student to hide behind nothing. All right, so at the end of this, I'm going to be asking Mila and I might ask Boo what exactly the kidney does, and they won't be able to tell me. But they give you a nice fancy 4 or 5 paragraph or something, and it might mean the difference between a 1 and a 2. So even if you write all that fluff, I want to see you telling me this exact thing there that Jawawan said. All right, it removes acids, and I think you're talking about urea. Newman control blood pressure. Your kidney need pressure to work properly. Control blood pressure. Let us not say that right now because I think you're talking about the afferent and the efferent arteriole. We'll get there, and I don't know that it really controls blood pressure. Kidney forms urine. Yeah, that is true. Urine is formed in the kidney. But the answer that I was looking for is that which Jawawan gave. Keep bones healthy. Yeah, we could talk about that as well. And we could, yeah, because the blood could become, yeah, we could talk about that. But like I said, Jawawan has the answer I'm looking for to get rid of waste and toxin substance. Toxic substance. Waste is this big word. You follow me? And I already hit it on the head. I like to say that hit it on the head and then you can beat around the bush afterward. Control blood composition. Yeah, Jawan, yeah, control blood composition with regulating the water and all of that. Yes. Kidney control blood composition. Yes. Amoy. Tanisha, get rid of waste product like salts, toxin, and of course, from the blood. All right, very good. I seen some nice things, and even the persons who I did not say yes, pattern, that is what I want. Your contribution helped as well because those persons who would have written vague things like these, they are now better able to write and present for the exam. So they can say, I am supposed to say that even if I have all this fluff, right? Because I don't want to leave and say the kidney is just removed. What are the substances that it removed? All right, beautiful. I think you did well just now. So, of course, the kidney main function is, of course, to remove toxin, and of course, it maintains a water balance in the body. Now, there is what we call the dorsal artery, right? And the dorsal artery would be carrying, we spoke about the aorta earlier, but the dorsal artery would be carrying blood to the renal artery, right? And of course, the renal vein. So we're now talking about this blood going to the kidney. So we said the dorsal. Remember the last time we were here, I gave you some position, and I gave you a position like ventral, dorsal, anterior, posterior, lateral, that type of thing. You remember we did that in the last show. All right, beautiful. So you see we're coming up with some word now that you have to understand what these words mean. So we talk about dorsal. So the dorsal artery is going to be taking blood to the renal artery. And you understand that the renal artery is going to be taking blood to the kidney. Now, this blood having been cleaned up in the kidney is going to leave the kidney by the renal vein. Now, having left the kidney by the renal vein, it is going to enter what we call the posterior vena cava. All right. So that movement of the substance there might be a little important. One other thing I didn't tell you before I leave, the excretory system. Forgive me. Let me stick up in here. You would understand that in biology we really don't use arrows to label. We don't use arrow to label. However, you'll see arrows in biology that signal flow direction, as it were, in the food chain, the food web, and of course, you would have seen arrows when you were looking at the excretory system. Please do not try to figure out that when you get to the exam, you're going to be seeing a colored diagram. The diagram might not be colored, it might be colored, I don't know. What is important is that you're able to identify the flow direction of a substance. So the arrow that is going towards the kidney from the top, that is going to be the one that is supplying the renal artery, right? So once you see these arrows, you must be able to identify the blood vessel. What is taking the blood to the organ versus what is taking the blood away from the organ. So even when you study to label these organs, you need to be able to identify the flow direction in order to label them. If you were given a blank thing and just some arrows on it, you should know what is what, pretty much like you should be able to say which is right and which is, of course, left. All right, that was very, very good there. All right, so we spoke about a lot of things with the kidney. It's time for us to get into the kidney. And this is going to be a little nice thing for me, getting into the kidney. And if I can get a piece, I'm going to ask somebody. Jason, you can look in the cupboard if you're seeing a red piece for me. You can just carry the pack for me, please. All right, I didn't have this plan, but sometimes when you teach, or while you're teaching, some things sort of come up, and you think that it's a good thing to use and teach, and I'm going to be showing you something if there's peas in the cupboard. Let me just read what we have here. Remove waste and extra fluid, yes, on the kidney, and then we have Panda saying the kidney act as a very, beautiful, as a very efficient filter. Yes, it is. Thank you. All right, so I got some peas just now. So I'm going to be showing you when we spoke about the kidney, I would say it's like a P, like it's like P shape. So I'm going to be showing you something. And what I'm going to be showing you now. All right, so I have a little piece here. So you see that little white part there? That is where we would have found the blood vessels, and that is where we would have found the urethra would have left the thing. So we're looking at the kidney. If I'm holding the kidney like this now, so this is the kidney. Which of the kidney is this, left or right? That's a beautiful one. You're looking at my kidney now. Which is it, left or right? My doctors. So I took the kidney out and I have it pretty much like it would have been in the body. Which of the kidney is this? Match the kidney to what is in your book. I don't know what you're seeing, but I know what I am seeing on the screen. So I think the white part that I'm looking at is closer to my face. That's what I'm seeing on my screen. So I want you to tell me, is this the right kidney or the left kidney? Based on where the blood vessels are entering the kidney and the urethra is leaving, which of the kidney this is? All right. So if I were supposed to put this down on the paper, you'd find that this kidney is going to be to my right. So if it is going to be to my right, then it's going to be the left kidney for that person. All right. So this is somebody's kidney I have in my hand, but that is not what I want to teach today. So it's also something to talk about position that I gave you just now. What I want to teach you using this kidney in my hand, I wanted to help you to identify the parts of the kidney. So I chose a piece. I've never done this before, but sometimes when the class is very nice, you get some real nice idea based on the nice students that you have. All right, so we're going to be looking at parts of the kidney. And when I teach parts of the kidney, I tell all my students to put their hand like this. All right, I hope you can see it, something like that. All right, something like that. I tend to tell my students to do something like that. And I'm talking now about the nephron. So I tell them that this area here is the Bowman's capsule. So this area that you're looking through my hand, it's a Bowman capsule. And then this region here would have been the proximal convoluted tubule. And then I tell them that this thing coming down and curve, this part here coming down and curve, that would have been the loop of Henle. And then my shoulder here would have been the distal convoluted tubule. And then my body would have been the collecting duct. That is what I usually tell my students. I don't know if it is really stupid or if it helps you, because a lot of students can't remember this nephron thing. So I just put my hand like this. And here you're looking through the Bowman's capsule. And if I were supposed to put my fist in the Bowman capsule, then my fist would have been the glomerulus. And then, of course, proximal convoluted tubule. Saying it is in proximity, close. All of these position words I tell you about, proximal, you remember we talk about, and I tell you about distal and distal, yeah. So proximal means that it is close, the tubule here is close to the Bowman's capsule. And then we have the loop of Henle, this long curve here, the anterior form, the long curve, you'll see it in your textbook. And then over here you have the distal, meaning that it is far. It is far away from this, so it's distant, distal. All right, and then we have the collecting duct. That is the nephron. We're going to be looking at the nephron now. So if you're looking in your book, we're going to be looking at the kidney itself first, looking at the location of the nephron in the kidney, and then we're going to be looking at the nephron itself. So I've just spoken to you and tell you a little bit about the nephron, or kidney tubule as it's called, and I just gave it that little bit because I'm going to be helping you to go through the kidney. So in going through the kidney, I'm going to be turning my piece around. In going through the kidney, all right, so this time, all right, I shouldn't confuse you. All right, so remember that the white part there is where the blood vessels are entering and leaving. And this would be more like the back part of the kidney. All right, so now I'm going to be talking to you, and all that I'll be saying to you, I'll be talking about the back part of the kidney. I don't even have anything. I'll be talking to you about the back part of the kidney. So moving from the back of the kidney, we are going in from the back, we're coming through the back door now, all right? So moving from the back of the kidney here, I hope you can see from the back of the kidney here, we are going to first go through the cortex. So the outer part of that kidney there is called the cortex. If you look in your book, you will see it. And the cortex tend to have a darker color. And then as you leave the cortex going into the kidney from the back, we're going through the back door, you are going to go to the medulla. And the medulla tend to have a lighter color. So we're coming from the back, right? So we know the parts of the kidney. So we are coming from the back door. We came through the cortex. And then where the cortex is very, very dark, apparently there's no light turned on in that room. And then we got into the medulla, and it has more light. Probably the light is turned on in that room. And then as we leave the medulla, we are going to enter the pelvis, right? And the pelvis, you don't know what is the pelvis? Yes, you do. All that the pelvis is a wider opening of the urethra that is connected to the kidney. Oh yeah. All that the pelvis is a wider opening of the urethra that is connected to the kidney. Let us step back a little bit. My book have cortex, lighter color, and lighter than the medulla. My book have cortex, lighter than the medulla. And what did I say? All right, tell me. I could make mistake. Tell me. I like that. Don't be gullible. All right, I soon take care of that. Now the Bowman capsule, the Bowman capsule is found in the cortex. The Bowman capsule is found in the cortex. All right. So let me just go back to this before I go a little bit. I might just leave it. Bertram, my book have the cortex a lighter than the medulla. The cortex is lighter than the medulla. I don't know if I said it the other way around. I'm very sorry if I did. So you have the cortex that has a lighter color, and then the medulla has a darker color. If that is not what I said, that is what I should have said. The cortex has a lighter color than the medulla. So we are coming from outside. The cortex is lighter in color, and then we have the medulla, which is darker in color. So if that is not what I said, I do apologize. That is what I should have said. If you have any error there or you wrote anything, please correct it. Bertram, my book have the cortex lighter than medulla. That is correct, Bertram. That is correct. Bertram, that is correct. All right, so let's get back to the thing now. So the cortex has the Bowman capsule, and the cortex also has what we call the proximal, or what we call the convoluted tubules. Some might call it proximal and distal, but we just call it the convoluted tubules. So the cortex is going to have the convoluted tubules, and of course, the medulla is going to have what part of the nephron? Type it in the chat there for me. I'm looking for two parts of the nephron that is located in the cortex. I did say something earlier that Bertram nicely corrected. Please stand by Bertram's correction. That is indeed the fact. All right? Good. We don't hide away from the truth. We are here to provide with the truth. And if we, sometimes coming directly from my head, but that is correct. All right? Very good. So the question now is that I said to you that the Bowman capsule and the convoluted tubules, they are found in the cortex. Now I'm asking you, what part of the nephron is found in the medulla? What part of the nephron is found in the medulla? Are you lost? If you're lost, tell me and I'll go right over again. Are you lost? Is everybody fine? Not too sure what's happening. So let me go again. The collecting duct, of course, is found in the medulla. What else is found in the medulla? Okay, go again. Beautiful. Should I go from the peas with getting into the kidney? That's where you want me to start from? That's where I lost you? Yes, the loop of Henle is also found in the medulla. But everybody got with the peas when we're identifying the parts of the kidney. We started from the back door. I would say the closest part to the back is going to be the cortex. And then as you get in, you get to the medulla. And from the medulla, we get to the pelvis. And then Bertram rightly corrected me, and Bertram said it is the cortex that has a lighter color, and then the medulla will also have a darker color. Everybody is with that? All right, beautiful. Now, if you are with that now, we moved and we passed that. Now that we are able to identify the colors, we want to identify how the nephron is structured or situated in, of course, the kidney. So we're looking at what we call the kidney tubules, and these are found in the kidney. But in the kidney, like we started out by talking about the part that is called the cortex versus the part that is called the medulla, the nephron is so well structured, well laid out in the kidney that there's a part of it that is in the cortex of the kidney, and there's a part of it that is in the medulla. Now, I said to you that the convoluted tubules and The Bowman capsule, those are in the cortex. I remember Bertram told you that this is the lighter colored area. While I think Amoy, was it Amoy? Amoy and others said that Amoy and Robertson rightly said that the collecting duct and the loop of Henle, these are found in the medulla. Is everybody comfortable? All right, beautiful. We move right along. So we want to know now, what is the function of the pelvis? What is the function? Type it in the chat there for me. What is the function of the pelvis? What is the function of the pelvis? Remember, you can come from your book. The show is supposed to encourage you to read, to follow the syllabus. I want you to follow me, follow me, follow me, follow me, follow me, follow me. All right? What is the purpose of the pelvis? What is the purpose? Okay, collects urine from the collecting duct. Anybody else? What's the function there of the pelvis? What's the function of the pelvis? Anybody else? We're asleep? I have one answer. Nobody knows? What's the function of the pelvis? Oh no, this is not good. What's the function of the pelvis? All right, so the pelvis, it pretty much collects urine from a uniferous tubule. All right, and this is of course linked to many collecting ducts. So some might go shortcut and say the pelvis actually collects urine from the collecting ducts. All right, larger collecting ducts. All right, collect urine from all the collecting ducts. All of those are correct. Different persons will represent it differently. Some might say uniferous, some might say collecting duct, some might say many collecting ducts, some might say large collecting duct, but pretty much the same thing. All right, so we're looking now at the loop of Henle. The loop of Henle. What's the function of the loop of Henle? What's the function of the loop of Henle? Type it in the chat there for me. Function of the loop of Henle. So we know that the pelvis is supposed to be collecting urine from the collecting ducts. Now we want to know what is the function of the loop of Henle. What's the function of the loop of Henle? Okay, the chief function of a loop of Henle, it is always going to be collecting water, reabsorption of water. All right, so the loop of Henle is of course going to be collecting a whole lot of the water, and we're going to be talking more about that. Tell me about the Bowman capsule. Bowman capsule. What is the function of a Bowman capsule? All right, so I'm going to be listening to you to the Bowman capsule and the glomerulus, after which I am going to be upping on into ultrafiltration and dive a little deeper into the nephron. All right, so as soon as you would have said what is we're talking about the loop of Henle, we're talking about the Bowman's capsule, we're talking about the glomerulus. As soon as you give me something for that, I am going to be upping right on to ultrafiltration. If you're just joining us, remember to like, share, and subscribe. If you want to be a part of a live chat, just come on over. You would have to be a YouTube account holder. And of course, you can take part in this live chat. This is where all views can contend, be it good, bad, or indifference. We listen to everyone. The show comes to us on a Wednesday at 5:05, Friday 5:05, and Sunday 5:05, all 5:05 p.m. And we're streaming live out of Jamaica. All right, so we have ultrafiltration, blood pressure forces. Uh, what are you telling me about now, Jawawan? Bowman's capsule is responsible for filtration. Uh, Thorpe, pressure filtration. Uh, Absorb water by osmosis from collecting ducts to concentrated urine. Not too sure what exactly you want to tell me about Bowman's capsule. All right, very good. All right, so let me just hop on into that. The kidney is really nothing without the nephron. It is within the nephron that all this fancy work that we spoke about, that's where it takes place. Now, the first thing we want to look at when we're looking at the nephron is a process that is called ultrafiltration. Before I dive into ultrafiltration, if you have seen any of the past paper that I have worked, we would have answered more than one question, sorry, with of course the nephron. And the question that we answered, you would have observed that we were asked to identify some blood vessels. The blood vessels had no arrows attached to them. It was pretty much something that was linked to the Bowman. It was actually linked to the glomerulus. And there was one of a blood vessel that was larger than the other. Now, when it comes to the nephron, the large blood vessel entering that Bowman's capsule, the larger blood vessel is going to be afferent arteriole. And the smaller blood vessel is going to be efferent arteriole. Now, this is one time when it is important for you to pay attention to size, because if you don't know, or if you didn't know the difference in size of the afferent and the efferent arteriole, then identifying these blood vessels on that exam paper, you would not be able to do so. So with ultrafiltration, it of course takes place in the Bowman capsule. And it is caused by pressure that is exerted on the glomerulus. And the glomerulus is pretty much a network of blood vessels. You would have the afferent arteriole being reduced to smaller blood vessels. And then, of course, it gets into the efferent arteriole. So ultrafiltration is this filtration, like I said before, that takes place in the Bowman capsule. What happened is that it is caused by pressure exerted on the glomerulus. Now, this pressure is, of course, created as a result of reduced size in the blood vessel. So we spoke about the afferent arteriole taking blood to this glomerulus. It's a large arteriole. It goes to the glomerulus where it is, of course, smaller blood vessels. And while it is leaving the glomerulus, it is in a smaller blood vessel. So then you understand that the pressure within the glomerulus is going to be great. And as a result, it's going to force things through the capillary into, of course, the Bowman capsule. Have I made myself clear? Anybody understand that? If you understand, just say yes. If you don't understand, say no, and I'll do it again. The principal function of a loop of Henry. All right, we soon take that. We're going to go back to the loop of Henry. All right, let's talk about ultrafiltration now. Ultrafiltration. So we're trying to get that thing for ultrafiltration. So in ultrafiltration, let me go again. what happens is that no. All right, beautiful, beautiful, beautiful. Am I? When you don't understand, you must say you don't understand. You know? When you don't understand, you must say you don't understand. Not the keep on knowledge, but I have a little bit can help. All right, so I'm going to be just drawing my little fancy diagram like I like to draw. All right, so I have this thing here. All right, not drawn to scale. So I'm going to be drawing a blood vessel coming in. And when it gets in here, it's sort of all mixed up like that. Don't worry yourself, I'm going to show you what I've drawn. And I'm going to draw in a blood vessel coming out. All right, this is not drawn to scale, but it tells the story I want to tell. All right, so we are talking about what we refer to as ultrafiltration. Now, this part here is called the Bowman capsule. This is the Bowman capsule. In here, you have some blood vessels we refer to as the glomerulus. Now, there is blood entering the glomerulus. But if you observe here, it is coming in a big artery, right? This artery is called the afferent arteriole. If you observe, the artery here is much larger than the artery on this side. So this is the afferent arteriole and this is the efferent arteriole. Now you are observing that there is no arrow to tell you which is which. But by the size, we are able to determine which blood vessel is taking the blood into the glomerulus. So the afferent arteriole is carrying this blood into the glomerulus. Then it comes into some smaller blood vessel here, and then eventually a smaller blood vessel. Now, because of this high pressure created, what it does, it forces stuff out of the glomerulus into, just let me draw that for you. So I'm drawing some arrow here. So it forces stuff out of the glomerulus, and of course the arrows will show into the Bowman capsule. Now, what is happening here is what we're going to now talk about as selective reabsorption that comes up next. So let me just go through that again. The Bowman's capsule surround the glomerulus capillary, a loop of Bowman capsules surround the glomerulus capillary loops and participate in the filtration of blood from, yeah. All right, so let us go with this again. Some persons didn't understand. We're talking about ultrafiltration. Ultrafiltration. Now, this is pretty much a filtration that takes place in the Bowman capsule. And we showed you the Bowman capsule just now. It is caused, like we said, by pressure that is exerted on the glomerulus. Now, this pressure is created as a result of a large arteriole being reduced to a smaller arteriole. Remember we said that? Now, the larger arteriole is called the afferent. It has a larger lumen or a larger space on the inside, and it is reduced to a smaller arteriole, which is called the efferent arteriole. Now, because this blood is being forced through it, what happens is that you have things that squeeze outside of the capillary, and it squeezes outside of the capillary and into the Bowman's capsule. Now, when it squeezes into the Bowman capsule, this is how the blood is cleansed. So let's talk more about some of the stuff. Are you with us now? Bertram? So the big one is the afferent and the small is the efferent. Perfectly so. Perfectly so. Perfectly so. So when you get to the exam, you must be able to identify the big one as the afferent and the small as the efferent. Very good. All right, so the afferent is the one that is taking blood to the Bowman's capsule, or we want to say the glomerulus. Then having left here, we are now going to have what we refer to as proximal convoluted tubule. And the proximal convoluted tubule, you'll observe in your book that it has many folds and it's pretty close. It is pretty close. It's pretty close to the Bowman's capsule. So that's the first place you're going to go. After you leave the Bowman capsule, you are going to go to the proximal convoluted tubule. And here, glucose is reabsorbed. In the proximal convoluted tubule, glucose is, of course, reabsorbed. And the reabsorption of glucose is done, or it is powered by what we refer to as active transport. Now, it's important to know that in the proximal convoluted tubule, that is where most of the absorption takes place. Now, one thing I should have said to you is that with selective reabsorption, absorption is taking place in two ways, two directions. Because around, I hope you're looking in your books, please look in your book at the nephron as I explained. Around the nephron, you are going to have a network of blood vessels, right? So you have things that are moving out of the blood vessel into the nephron and things that are moving out of the nephron into the blood vessel. Are you with me? So let us start again. So with the proximal convoluted tubule, glucose would have been reabsorbed out of the nephron back into the bloodstream, right? And we're saying that most of the substances that are reabsorbed back from the back from the nephron to the bloodstream take place here. But we're also saying that some toxic substances that were not removed in the Bowman capsule, they are going to be removed from the blood vessel now into the nephron from these blood vessels that are close to the nephron. So here we were saying that glucose was pretty much moving from the nephron into the blood vessel. No, it is not that bad. It's not that bad. It's not that bad. I don't know. A YouTube flag that comment that you made just now. All right. So, oh God, let me hope that I'm not scaring you guys. All right. So glucose is absorbed in the proximal convoluted tubule. Right? We're saying, let me go again. We're saying that which was not absorbed in the Bowman capsule is reabsorbed in the proximal convoluted tubule. A lot of it is reabsorbed there. So we're saying that the glucose that was in the nephron over there in the proximal convoluted tubule is a part of the nephron, you know. So we are saying that glucose would have been reabsorbed from the proximal convoluted tubule back into the blood vessel. But we are also saying that if there were toxic substances that were not removed in the Bowman capsule, they are now going to be removed from the blood vessels that are very close to the proximal convoluted tubule. So in this case, the toxic substances will be removed from the blood and they are going to go into the proximal convoluted tubule. So one at a time, let me say that again. So here at the proximal convoluted tubule, you have glucose coming out of the proximal tubule into the bloodstream. And at the same place, you have toxic coming out of the blood going into the proximal convoluted tubule. Is that better? Sir, what is the difference between the proximal and distal convoluted tubule? Like I said earlier, the proximal convoluted tubule is closer to the Bowman capsule. The distal convoluted tubule is a little distant away. It is closer to the collecting duct. And we're going to be looking at what happens in the distal convoluted tubule. But let us just solve what is taking place. And of course, a little more stuff takes place, but what I'm giving you is more a summary of what happens with the proximal convoluted tubule. So what I said Glucose is reabsorbed by active transport, and this is coming out of the proximal convoluted tubule now into the blood. I also said that some toxic substances that were not removed from the blood, they are going to now be removed from the blood and they are going to go into the proximal convoluted tubule. So what you have happening is that substances are moving in both directions, right? It's not something that it is just moving from the blood into the convoluted tubule. No, that's not how the nephron works. All right, and we said that most of what happens, it happens here. Now, water is reabsorbed by osmosis from the loop into the capillaries. So water has been absorbed, and while the bulk of the water or most of the water will be absorbed in, of course, the loop of Henle, we're having some water that is, of course, being absorbed as well in the proximal convoluted tubule. All right, my book don't have those words into proximal tubule word is first. All right, yes, first convoluted tubule, yes. And then the distal is that which I refer to as the second convoluted tubule. Yes, that's the same thing. So the first convoluted tubule is the same thing. We say first, and remember I said, first proximity. So your neighbor is in proximity. So this is your proximal neighbor, right? And the person that is way down the road, the second person down the road, that is in distance. So we say distal. All right, so we have proximal and we have distal, and we have first and we have second. It's pretty much the same thing. By virtue of you mapping it nicely like that, it means that you understand pretty well. All right, I do hope that I'm not losing anybody here. I do hope that this is not too much for persons. We're going to be continuing. We're going to look at reabsorption of the glomerular filtrates. All right, do we have any questions before we move on? I don't want to kill you with it. I know that persons are afraid of the nephron. If you still don't understand, I'll send you a video of the nephron. I send you a link for the video of the nephron so that you can go and see what is happening with the nephron. Because probably if you see it, it probably would mean a little more to you than me explaining or the book just showing you a picture. Probably a video would do a lot. All right, so in the glomerulus filtrate, I will talk about glomerulus filtrate. We're talking about now what is going in the Bowman's capsule. You are going to have the glomerulus filtrate. What is going to be filtering is, of course, glucose, water, and salt. Now, what will not pass through is, of course, large protein and blood. Those will not pass through the capillary. All right, large protein and, of course, blood. Now, reabsorption is from the Bowman capsule to the blood vessel. And this type of reabsorption is what we refer to as the renal dialysis. So reabsorption from the Bowman capsule to blood vessels is called renal dialysis. And I'm going to be going through renal dialysis again in the program. All right. Okay, so somebody say, yeah, they want to see a video. It would work better if they see the substances moving and all of that. Fine, I'll send the link for a video. All right, so we're up and now down to further deeper into selective reabsorption. And selective reabsorption, metabolic activity, enables selective reabsorption of substances from tubule. Now, this happens in both directions, and I said that earlier. So somebody had asked earlier about the distal convoluted tubule. And in the distal convoluted tubule, there's, of course, reabsorption mainly of salts. So we talk about glucose, and we talk about toxin, and we talk about water in the proximal convoluted tubule. So we are saying in the distal convoluted tubule, what is really reabsorbed is, of course, salt. Now, in the distal convoluted tubule, it is chiefly responsible for controlling salt concentration of the blood. So if you are controlling salt concentration of the blood, you can easily say that the water balance will also be maintained. And the water balance is going to be maintained by, of course, what we refer to as diuretic. You will remember this ADH. You can recall that? Antidiuretic hormone. All right. So we're looking at the distal convoluted tubule. Somebody asked earlier about the distal convoluted tubule. Now, the distal convoluted tubule is going to, of course, with the aid of ADH, control water concentration of the blood. Now, it will not allow the blood to become too concentrated. It won't allow the blood to have too much salt. So it will always, this is like the last phase of reaction, of reabsorption, sorry. It is like the last phase of reabsorption. So the distal convoluted tubule, the second convoluted tubule, as some persons call it is now going to make sure that it regulates the concentration in the blood. It will not allow it to have too much salt, neither will it allow it to have too much water. Now, I don't know if you've ever heard the term diuretic. Now, diuretic increases urine production. A diuretic increases urine production. An example of your diuretic is going to be alcohol, medicine, and so on. And not all medicine. Doctors will give you, of course, medicine that will, or medication that will increase your production of urine, and you'll be able to pass more urine as a result of, not too sure, regulating your blood concentration or regulating the amount of water in the cell. Now, ADH, what happens with ADH, as we spoke about the proximal convoluted tubule? The ADH controls the permeability of the distal convoluted tubule. And we talk about permeability, we are talking about those tiny space, the membrane, how much things can go through in whichever direction. So what ADH does is to control the permeability, allowing stuff to pass through in the distal convoluted tubule and, of course, the collecting duct. Now, urine is the end product of selective reabsorption. So all we have said just now is a whole lot of stuff that seems a little contrary, but I'm going to be summarizing all that I have said just now into 6 little steps. So the first thing we are going to have in the stage of urine formation, which is the same thing, we're talking about how the kidney work. We're going to talk about the 6 stages. Very simple thing. So the first thing you need to know, you probably need to jot them down. The first thing is that you are going to have ultrafiltration. That is how we started out. Ultrafiltration. Then we are going to have selective reabsorption, right? So reabsorption, meaning that the blood is going to take back some stuff, right? I don't want this to go out in urine, so I'm going to take it back. So ultrafiltration, things go into ultrafiltration, things move from the blood into the nephron, right? Selective reabsorption, things now are moving now from the nephron back into the blood. So 1, ultrafiltration, selective reabsorption. Now the third phase, waste that is added to the tubule by the capillary. ATP is going to provide energy for the reabsorption, right? So some of the stuff that was actually, like for example, glucose that passed on over in the into the loop of sorry. For example, glucose that has been passed over into the nephron. ATP is going to provide that energy to take back the glucose from the nephron into the blood vessel. So let's start again. Ultrafiltration, selective reabsorption, ATP providing energy to bring back some things into the blood. And then the fourth thing now, so you realize that up here, so we talk about ATP, we're talking about the proximal convoluted tubule. And then now we come down to the loop of Henle, which is the fourth step. Now, in the loop of Henle, water, the big thing that is reabsorbed in the loop of Henle is water. And then the fifth thing now is that when we talk about fifth, you know that now with the overwear, the distal or the second convoluted tubule. So the blood concentration, we'll start talking now about blood concentration. Blood concentration, the right tubule content is now urine. So the blood concentration, the right concentration of the blood is going to be monitored over there in the distal convoluted tubule by we spoke about ADH, and that having been done, water being reabsorbed, the concentration of the blood is right, then the final phase there is going to be urine. And the urine is going to be collected by the collecting duct. Now, the urine now having been collected by the collecting duct, then you understand that now you have clean blood. And the clean blood, which is of course deoxygenated blood, is going to now be passed on into the renal vein, which is now going to take the blood to the vena cava, back to the heart, and circulation continues. So I hope we understand that. So let's go through that again. First, you're going to have ultrafiltration, then you're going to have selective reabsorption, where things are going to be reabsorbed like water and salts and glucose. And of course, in the proximal convoluted tubule, ATP is going to provide energy to reabsorb some glucose. And then we are going to move on down now into the loop of Henle, where water will be reabsorbed. And then the blood concentration, the right concentration there, will be controlled by, of course, the distal convoluted tubule and the effect of ADH on this region, the collecting duct and the distal convoluted tubule, where it is, of course, allowing for more reabsorption or better regulation of the water content in the body. And that pretty much is what happens with the urine production, and then the good blood will, or the clean blood will now re-enter the bloodstream, go to the heart and come around again, and we have nice clean blood. Now, the sad thing about that, it's very important that you understand what happens in the loop of Henle. I realized that for a lot of persons a while ago, there was so much being said, and persons don't even know, understand which direction the thing is moving and all of that. Over time, you'll get it. It's sort of hard to understand. It's sort of abstract with me just talking, and you're not. Some persons not even know what are these things that I'm talking about. Now, if the loop of Henle is not working, then we're suffering from what we want to call kidney damage. Now that you fell asleep, I'm going to wake you back. What causes kidney damage? Type it in the chat there for me. What causes kidney damage? Type it in the chat there for me. What is responsible for kidney damage? What are some of the stuff that are responsible for kidney damage? All right, so we have just looked at the loop of Henle. It was something tough. A lot of persons were almost bowled by, not the intent. It is never ever the easiest. It's never ever the easiest thing to understand, as it's a very abstract thing. Persons have never really seen a loop of Henle, but I can assure you that if you were supposed to break it down in the various parts, the Bowman's capsule, the glomerulus, the proximal convoluted tubule, the loop of Henle, the distal convoluted tubule, the collecting duct, it would make it very, very easy for you to understand. So that is not something for you to worry about or say I have to give up because I can't manage. It is very, very easy. Just take them one at a time. Don't try to do them all as I did just now. Just take them one at a time. So we're looking at some of the things that would cause the kidney to be damaged. So some persons are saying alcohol, which is of course a diuretic, which is going to cause more urine to be produced. But one other thing we need to remember about alcohol is that all alcohols are acids. All alcohols are acid. They might be weak acid, but they are, of course, acids. Smoking, to an extent, is said to affect the kidney, and we're going to be talking about that. And if you have diabetes, that will affect the kidney. So we can easily talk about high blood pressure too affecting the kidney. That could cause kidney damage, and infections, those could cause kidney damage. Now, how do we correct this problem? Sugar level. Yeah, how do we correct this problem? Now, the correction for the problem is, of course, going to be one, first, medication, right? We could now talk also about adjusting the diet, ensure that the diet is one that is balanced, and of course, if it's balanced, it is going to meet your nutritional requirement. Then, if diet is not helping, medication is not helping, then you might have to do a dialysis. Be a part of the renal clinic, and you're going to be going to the renal clinic to do what we refer to as a dialysis. I will tell you more about the dialysis. And if the dialysis doesn't help or it's not helping, then the other thing to do is to do what is called a kidney transplant. Now, with the kidney transplant, what happens is that usually the failing kidney, unless it's inflamed or ruptured or something like that, they are not going to be removing that kidney. They tend to put another kidney from the donor in. So at that time, you remember the early part of the show, I said that you're going to be hearing about a time when a person has three kidney. This is the time when you do an operation, they're going to attach another kidney, not to remove one of those inside of you, and that those inside of you, they are really, really damaged. If they are not really, really damaged, you're not going to remove it. Now, the dialysis process is one in which you will go to a clinic because the kidneys have failed. And of course, if you are not able to clean the blood or cleanse the blood, as one would say, then of course you understand that we are going to have a toxic buildup. And when you have a toxic buildup, you are going to either have water being stored in the body, and the body starts swelling, and the person might say that you are fat, but you are really just retaining more water than you should. Or you might have a toxic buildup where the skin becomes dark, and you start having lesion or sores on the skin. Now, you don't want that to happen and you want to live as long as you can, then you would probably have to start going to the renal clinic. I think you go to the renal clinic before you even do a kidney transplant. If that is not helping, then that is where you do the transplant. The renal clinic is usually about 3 sessions per week. I think if you are in Jamaica, I think one is at KPH. About 3 sessions per week, and each sitting is about 4 hours. What happens is that your blood is removed in that you are connected. I think they connect a tube to the artery, and this is led to a substance we call heparin. The purpose of the heparin is to thin the blood. Then the blood would actually enter the dialysis machine. And of course, there's this dialysis fluid that it flows through, and the dialysis fluid it goes through one end, and the blood would come through another end. But it goes through pretty much a membrane, pretty much like the kidney tubule. It goes through a membrane that filters and removes the unwanted stuff. Then it re-enters the body by the vein. So you'd have to do this at least, I said, about 3 times per week. And for each sitting, it is about 4 hours. All right. So that pretty much sums up if the kidney were to be damaged, causes of kidney damage, and of course, it looks at the prevention, the cure. Now, one other thing you want to ensure that you have a healthy diet. You want to exercise and stay safe. You want to stay away from cigarette smoking. You want to stay away from bad air. You want to ensure that you have good air. I might be talking about the lungs now, but if the body is just not healthy, it's going to affect just about all the organs over time. Now, we want to talk a little bit about the composition of urine. Now, what is urine made of? Urine is, of course, made of water, urea, sodium chloride, which is salt, mineral, and of course, nitrogenous compound. We spoke about urea. All right, so it's made up of nitrogenous compound, and we spoke about urea and all those stuff. All right, so that is pretty much what we have for you on the kidney. A lot of persons are with the nephron. Like I said, I am going to try as much as possible to find a video a link for a nephron, a good video link for a nephron. I haven't done anything on the nephron as a video, and see if I can put it in the description for this video, so you can hop on over there to look at the nephron. I'll try my best to find one. All right, the skin is the final topic, I realize that a lot of persons are almost out, but never mind. The skin is probably one of the easiest topics, among the easiest topics. So I'm going to ask you to just find the skin in your textbook so that when I go through, you will ensure that I am on point. All right? Doing it for about 2 hours now, just talking, talking, talking. You have to be careful you don't remember anything and you don't put X where Y should be and Y where X should be. So I want you to follow in your textbook as I go through. All right, everybody, all right? Good, 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 good. All right, but a question I want to ask. Everyone has a skin? I don't know. You all have skin? Yes, no. Yes, no in the chat. Do we all have skin? Everybody have skin? We're asleep? Is there anybody here without a skin? Oh my, they're sleeping. What's happening? Okay, so Tanisha has skin, I'm sure that she said it, but I don't know about the others. It might be skinless. All right, so the skin is that outer covering of the body we like to call. It is probably the largest organ in the body. It is that organ that is referred to as the integument system, and it produces sweat. That's what we know about the skin. The skin produces sweat. Now, the sweat is composed of what? We spoke about that earlier. The sweat is composed of water. What else? The sweat is composed of water. I have to wake you up now. I have to give you a lot of the work to do. The sweat is composed of salt and water. That's all. The sweat is composed of salt and water and what else? We soon finish. We are supposed to go for 2 hours and we soon finish. Traces of course, urea. Now, this is the interesting thing about sweat. Is sweat an excreted product or a secreted product? Is sweat digested? Is sweat excreted or is it a secreted product? Anybody can answer that question? Is sweat a excretory product or a secretion? Excretory product. Anybody else? Is sweat an excretory product or a secretion? No, sir, I have no skin. Bertram, you don't have any skin. What you have? Tell us about it. Shell? I don't know. I'm going to join a maths class now. All right, Treasure. All the best. Take care. The video will be online. Thanks much for stopping by. All right, good. All right, so the skin is both an excretory organ and the organ that, of course, produces secretion. Now, when we talk about the skin producing sweat, as it were containing heat and salt and water and urea, of course, that is going to be excretion. But when we talk about the skin as in cooling the body, it is producing some water to cool the body or putting out water. It is, of course, a secretory organ, or organ that secretes. All right. Now, when we talk about a secretion, it is not the same thing as excretion. It is not the same thing as egestion. A secretion is, of course, a useful substance that is usually secreted by the cell for some purpose in the body. All right. So we spoke about excretion, we spoke about egestion, and we spoke. Now we're now talking about secretion. So excretion, egestion, and secretion. Now we'll move on a little deeper into the skin. The skin is chiefly made up or primarily made up of two layers. All right, there is the epidermis and of course the dermis. Now the epidermis has just below it that which we call the Malpighian layer. Can you see that on your diagram? Tell me. We're going through the diagram now. We're looking at the Malpighian layer. The Malpighian layer. Tell me if you're seeing it on your diagram. Malpighian. We're not all sleeping. All right, so just below the epidermis there, we're going to find the Malpighian layer. Now, the Malpighian layer, when they die, the cells in the Malpighian layer die, they form cornified layer that, of course, protect the body. Now, the Malpighian cells, they are short-lived. Your Malpighian cell, they are going to be there for probably about 3 weeks. Now, then we have the outer epidermis, which is made of dead cells. Now, they continue to shed, the outer epidermis, they continue to shed, and they will fall off in your house, your bed, all around. And from time to time, what will happen is that you might have termites or other things helping with them being broken down to smaller units. And of course, these could cause you or cause you to develop or have some amount of allergy. And that is one of the reasons that we have to ensure that we clean our surrounding carefully and regularly, because of course we have cells that are falling off daily. Now, the Malpighian layer is the area where melanin is made. And of course, you know that melanin is that pigment that gives the skin the color. Now, the melanin protect the skin from harmful ultraviolet lights. All right. So melanin protect the skin from harmful ultraviolet light from the sun. Sorry, I was just looking at some message from my workplace. It is, we were talking a little bit a while ago, sorry about that. We're talking about melanin, and we're saying that melanin is made in the Malpighian layer of the skin, and the purpose of the melanin is to protect the skin from harmful ultraviolet light from the sun. Now, there are cases where persons are without melanin, as in the case of the albino that we spoke about when we did genetics, but we're going to be doing it again. Now, where there's a lack in melanin and we have excess exposure to the sun, we are going to suffer from burns, which could eventually lead to skin cancer. Now, the Malpighian layer is also that layer that is responsible for our unique identification that we call the fingerprint. Then there's this layer of the skin that we want to talk about that is called the dermis. And the dermis, it has connective tissue. It has, it's pretty much made of elastic fiber. It has many blood cells and what we refer to as the ear follicle. Right? The ear also gets its pigment here. It is in the dermis that the ear is going to get its pigment. Now, one other thing we need to know is that gray ear is gray because it would have lost its pigment. Now, the sweat gland is found in this area, nerve ending, and of course, the sebaceous gland is also found in the dermis, and it secretes oily substances we refer to as sebum. Now, the purpose of the sebum is that it, of course, keep the hair flexible, and of course, prevent cracking in the skin. So the main function there is, of course, to protect the ear and, of course, the skin. We're coming down to the end of the show. Now, the ear your ear should not be washed too often. Because if you wash the ear too often, what will happen is that it will remove sebum and make ear brittle. It will remove sebum and it will also make the ear brittle. Now, the function of the skin, I'm going to quickly tell you about them. And then we're going to take up on temperature loss and gain in our show on Friday. And we're going to be looking at, of course, homeostasis. So some function of the skin would include excretion, think I'm out of time, excretion, secretion, protection, temperature regulation. It is responsible for vitamin D production, and it is also a sense organ, and it regulates water loss. All right, so there we have the function of the skin. We have now what we refer to as heat and temperature regulation. I'm going to be asking you some questions now because I feel like you're falling asleep on me. I want you to tell me what is temperature. I also want you to tell me what is heat, what is temperature, and what is heat. Tell me what's temperature, tell me what is heat. What is temperature, what is heat? What do you understand from temperature? What do you understand from the term heat? Now, it's important to note that temperature is measured using a thermometer. Temperature is measured using a thermometer. What is temperature? Tanisha, temperature is, of course, is it temperature? Temperature is, of course, how hot or cold something is. Pretty much that's what temperature is, a degree of hotness of any object, whether it is hot, cold, or in between. That speaks to temperature. Now, what is heat? Heat is the total amount of energy in an object. That's all it is. So when we talk about heat, we're talking about a form of energy. When we talk about temperature, we're talking about hot or cool, or hot or cool a substance is. Now, temperature regulation of the blood is done by a special part of the blood. Can you tell special part of the brain? Can you tell me what that part is called? A special part of the brain that the blood would flow over in order to regulate the temperature of the blood. What is that special part of the brain called? It begins with an H. What is that special part of the brain called? Special part of the brain? It is called the hypothalamus. And pretty much the hypothalamus serves like a thermostat in controlling the temperature of the body. Now, there's also what we refer to as, so the hypothalamus is in the brain, right? And as soon as blood passes over the hypothalamus, it can detect how hot or cold the body is. And of course, it is going to, of course, stimulate or ensure that it gets into its regulatory mode in order to protect the body from hyperthermia or hypothermia. But temperature receptors in the skin also pick up on the temperature of the body too and the environment. So there's also a temperature receptor in the skin that is helping with the regulation or the regulatory effect of the body's temperature. All right? And it causes us to make voluntary decision. So the receptor in the skin, that is going to cause us to make decision. Now, some of the decision that we will make is whether we put on some clothes to get cold or remove some clothes to get cold, or put on some clothes to get warm, sorry, or we're going to remove some clothes that we get cold, or we might choose to turn on the heater or turn off the heater, or we might choose to turn on the fan or turn off the fan, or we might choose to go into the sun or go into the shade, that type of thing. And all that is pretty much driven by the temperature receptors in the skin. Now, things like vasodilation and vasoconstriction, those are going to be powered primarily by the hypothalamus, right? But both regulatory organs, are both regulatory parts of the body. They are going to help to control the temperature of the body, the temperature receptor in the skin, and of course the hypothalamus. And remember, what we don't want to have, we really don't want to be experiencing what we call hyperthermia, where the body is uncontrollably hot, like when you're having a fever out of control that could cause you to die. Or hypothermia is when you are extremely cold. Hyperthermia is when you're extremely hot. So hot, cold. All right, beautiful. Now, heat gain and heat loss. How the body gains heat? Tell me in the chat. What do you do to get warm, or what the body does to get warm? Tell me in the chat. You want to get warm, or the body wants to get. All right. The driving force of our body temperature. We spoke about that when we spoke about energy transfer. The driving force for us being warm as mammals and birds, I told you that before, is respiration. So respiration is going to generate a whole lot of that heat energy that keeps the body warm. Now, we also generate some amount of heat in the body, increase the temperature of the body by one, shivering, which is an automatic reflex action where the muscle under the skin pretty much contract and relax very quickly in order to generate a whole lot of heat to get the body warm. We also generate some amount of heat in the body through exercise, and the liver in its function, because this organ is so large in its function, it too generates some heat. Now, there's also heat coming from the environment as radiation and as conduction. This too is going to help to, of course, increase the temperature of an organism. Now, another thing that could cause you to gain heat or increase in temperature, infection. Now, there are a lot of persons get some warm. All right, so we could get some warm soup. We could get warm skin, stop producing sweat muscle. Oh, we're not there yet. Yeah, we're going there. We're going there. We're going there. We're going there. All right. So if we have an infection, that could also increase the temperature of the body. And the temperature of the body is increased primarily now. Persons who are taking the COVID vaccine, in some cases, the body temperature is going up having taken the vaccine. And we're going to be looking at that when we look at immunity and what is happening there. So the body gains energy that way. Now, Amoy went to vasoconstriction, where she's saying, with vasoconstriction, it's a topic I'm going to do by itself. Just give me 1 second. All right. So we also, fever. Yeah, you have a fever when you have an infection. So pretty much that's a fever, that high temperature fever. Now the body, we spoke about gaining energy just now. The body also lose energy by sweating. And I want to talk a little bit about sweating. You can sweat and don't lose any heat. All right. Now, when you sweat, what causes you to lose this temperature is the sweat being evaporated from the skin. So if you are in a room that is not so conducive to you losing or the sweat evaporating very quickly, you are going to be hot and the sweat won't be effective. Sweating won't be effective. If the day is highly humid, also this could also cause a problem. So you want to ensure that you are in an area that is highly or well ventilated when you are sweating to get rid of that heat energy. Now, another thing is that the fan will help to cool you. How the fan does this is that the fan will increase the rate at which the water is leaving the skin. And because this heat energy is being lost, then you'll find that the body is becoming cool. Now, AC remove water from the air, and it removes the water from the air very quickly. And of course, that causes the sweat to also evaporate quickly. So of course, the AC will also help you to lose some water. Then we could talk about vasodilation. Now, vasodilation will cause you to lose some heat energy. And what vasodilation does, we need to talk about vasodilation. As the word suggests, dilate, the blood vessels will become bigger. So once the blood vessels become bigger, the blood is more, it is actually carrying more blood. But the blood is flowing closer to the skin. We usually talk about it as being flush, the skin being flush. So the blood flowing closer to the skin, what will happen is that the skin will tend to appear, the skin will appear to be red, right? Now, the pores in the skin will open to allow more water to escape. Now, the ear on the skin, they will fall down or come very close to the skin so that they are not trapping any AIR. So that they're allowing air to flow quickly over the skin in order that the water can evaporate as you sweat. Now, sweating is also going to be one of that thing when in vasodilation, we are going to produce a lot of sweat and it's going to be leaving or expected to be leaving very quickly in order to cool the body. I said earlier during vasodilation, a whole lot of blood is carried in the arterioles or in the artery, arterioles closer to the skin and capillaries, so on, in order to cool the body very, very quickly. Now, Amoy spoke earlier about vasoconstriction, right? And she's saying that vasoconstriction is going to, of course, save the body some heat energy. What happens here with vasoconstriction is that the blood vessels now go deeper into the skin. And as they go deeper into the skin, they also become smaller. That means they constrict. Now, when they constrict, they are carrying less blood. And in carrying less blood and moving away from the skin tend to be a little cooler, as one would say, cool like me wash my face with whatever, right? So you go to the bathroom and you wash your face, and what will happen is that the skin will seem a little pale because what you have done is to cool down the skin and the blood vessels will go deeper into the skin. And of course, the ear on the skin, the ear on the skin will become erect, right? During vasoconstriction, the ear and the skin will become erect. And why the ear and the skin become erect? It is because it is trapping AIR and forming an insulator. All right. So we spoke about in vasodilation. When you get hot, the blood vessels come closer up to the skin so that you can lose. In vasoconstriction, the blood vessels go down in the skin. You appear to be a little cooler. The skin appear to be a little cooler, as they would say, but you are pretty much conserving or closing the pores to lock the heat inside. The pores are closed, and of course, there is no sweating in vasoconstriction. And of course, the skin, like I said earlier, it is cool. It appears to be pale. All right. So that is what happens during vasoconstriction. Then there are these two words that we are trying to safeguard ourselves from when there is control of temperature, be it temperature loss or temperature gain. The hyperthermia and hypothermia. So hypothermia is low temperature, hyperthermia is high temperature. And when the body is constantly hot, a number of things could happen. Now, you could faint, you could have a heat stroke. If it is not controlled, you might have organs that are damaged. It could lead to death. And of course, stress on the heart, as the heart is fighting to pump that blood so quickly in order to get rid of the high temperature. Now, hypothermia, a person who is suffering from hypothermia, is usually somebody who is exposed to this continued cold environment and the body just can't treat with it. So, what is going to happen is that, of course, you're going to have less blood flowing as the arteries are going to constrict. And as the arteries are constrict, then you'll find that the person it might lose consciousness. The person might become weak because everything is reduced, shutting down in the body. And if this is not taken care of well, quickly, the person might eventually die. Now, with hypothermia, the body is going to chip in its mechanism of generating some heat, and the person is going to shiver. The person is going to shiver. Now, I've seen this on a past paper. The sebaceous fat act as insulator, and of course it is also going to provide some amount of nutrient if that is needed for respiration. So when a person is suffering from hypothermia, the sebaceous gland is also there as insulator, helping to keep you warm. And there's also shivering taking place in order to generate a lot of heat energy. As we have said earlier, the muscles are going to contract and relax very quickly under the skin, and that is going to provide a great deal of energy. Now, in birds, for the bio students, I don't think that there's a better place that you can see the erector muscle in use. The erector muscle is going to actually cause the feathers to become erect when, of course, the bird is cold. And this is as a result of trapping AIR to provide this insulation so that, of course, it can be warm. So the bird tend to do that. Another thing about birds is that birds tend to eat a lot and they're able to regulate their internal body temperature, or regulate the body temperature based on internal mechanism. Now, I will refer to these two organisms, birds and mammal, as homotherms because they're able to internal regulate their body temperature using internal mechanism. Now, the poikilotherms are the cold-blooded organisms, as we call them, which would have referred to things like the reptile, the fish, the amphibian. They regulate their body temperature using external means. So you'll see a crocodile on a stone eating up on that type of a thing. And if it's too hot, you'll see them in the mud or in the water, that type of thing. So the poikilotherms, they tend to regulate their body temperature using outside mechanism, while the homotherms, which are only mammals and birds, they regulate their body temperature from inside. Now, the last thing we're going to cover this evening for the presentation, we're going to be looking at skin protection. How can we protect the skin? Tell me in the chat. This is going to be your part as I look, read, listen, and remind us to like, share, and of course, subscribe. Please be reminded that the show comes to you on Wednesdays, Fridays, Sundays at 5:05 p.m. All right. So one thing that we can use to protect the skin is sunscreen. Anything else? I want to hear from everybody. This is going to be the last part of the show for this evening. A lot of persons are falling asleep. We are way behind time because I think the show is 1 hour later or something like that. All right. Don't bleach the skin. Yes, you shouldn't do that. You're going to damage the dermis, the epidermis, everything there after a while just get affected by bleaching. What else we shouldn't do? Use sunscreen. You want to ensure that you stand in shaded areas. Use an umbrella shaded area to ensure that you are not exposed to the harmful ray of this ultraviolet light or the light coming from the sun. What else we need to do? Come on, guys. This is the last part of the show for today, as we are going to be picking up on Friday on homeostasis. You shouldn't use hard soap to bathe. Hard soap will, of course, yes, that is true. Our soap, pretty much our soap they use to bleach. Anything else? Avoid the sun during the hottest part of the day. Good. Use an umbrella like Tanisha. Anything else? You want to ensure that you bathe, have a shower at least twice per day, not too much, because of course you'll damage the skin. Avoid smoking, avoid skincare products containing alcohol. That's another one. All right. Do not smoke. This will cause the skin to age very, very quickly. You want to eat a healthy diet. Eat a healthy diet. And of course, you want to use moisturizer to keep the skin moist and healthy. Moisturizer like good lotion, not just about any lotion. And of course, you want to manage your stress. Don't sit and go thinking about everything in the world that you really have no control over. Manage the stress. And the last thing on my list is going to be drink adequate water. So we spoke about diet, where you need to drink a lot of water. You need to exercise. We didn't say that, but you need to exercise, drink water to ensure that you have skin that glows. And if you have a baby, you want to ensure that the baby is getting adequate breast milk so that the baby can have healthy skin. That takes us to the end of the show today. It was a really trying period for us. We logged on 4 times before we could have started, before we got the show started. But nonetheless, we're here and we were able to make it through. So there are some diagrams that you need to know here. You could just type them in the chat for your colleagues. You need to know the diagram of the skin inside out. Be able to label it, be able to annotate it. You need to know that. You need to also know the kidney. You must be able to label and draw the kidney if you're a biology student. You need to know the nephron. Biology student is always to label and draw, while HSB is usually to label. You also need to know the excretory system. So I gave you 4 diagrams there that you need to know. You need to know the excretory system, the kidney, the nephron, the skin. All these are diagrams that are pertinent to the topic that we have just covered, and it's very important that you know them. If you don't know them, you could be setting up yourself to have a little challenge when you get to the exam. I found just now that it was a little difficult for a lot of persons to follow when I went through the nephron or the Bowman capsule. I suggest that you go to your textbook now that I have said a lot about it and do a little reading on it, and you should be better. Sir, before you go, what organ remove large quantity of water from undigested food? The colon. The colon. All right, am I? The colon. Remember, that is the purpose of a colon. So most time when we talk about water being removed, we're talking about the loop of Henle or the colon. And if you go to digestion and look for colon, you will realize that the colon is the big thing there for water reabsorption. All right, because remember, when we did digestion and we said that the food came down, the chyme came down and it went to the small intestine and absorption take place and all of that. What you find happening, yes, the colon, the large intestine, as this soft product went through the colon, as it went ascending, transverse, descending, as it moved through, water kept moving out of it, and then it became a little harder and a little harder and a little harder and a little harder, to the point where we pass it out as much harder than it was. All right, so pretty much that's it. Like I'd like to say, thank you very much for joining me. It is always my pleasure to be here with you. I do hope that we're studying as much as possible. Listen to the videos as much as possible to the past papers. No HSB student can complain about not having adequate multiple choice paper. Yes, I know I have the paper to work on, but it's exam time at school, so I am trying my best to sort of manage both. I am working on the other stuff on the channel. You would have seen me putting up some stuff for CSEC IT. If you are doing CSEC IT, check them out. We're doing Excel. We're doing everything on Excel, and then we're going to get on to the other programs. We don't want to do everything one time. We're taking our time to make sure that we don't burn out. All right. So again, thanks so much for joining. Remember, next time when you come to carry a friend, remember to like, share, and of course subscribe. On Friday, we're going to be looking at homeostasis, and we're going to be completing that, and we want to ensure that everyone is here for that. But like we said, we don't want you to turn up on Friday and you did not go through the nephron, because the fact that you were struggling with the nephron today, I felt it. I can feel that energy. The fact that you were struggling with the nephron, we probably have to just revisit the nephron by itself. I probably have to just carry some diagrams here and label them so that you can see them and do the explanation again. But I don't know that I am so comfortable with how you responded when I gave you content on the nephron. So we might have to revisit that. And that is why I like to say when I ask a question in the chat, I want everyone to answer, because when you answer, it gives me a good idea of how much you're following the lesson. So we might very well have to revisit the nephron, though we're going to try to send you some video on it. I'm not too sure that we will, but we will try. But if we don't, we're going to be revisiting the nephron from Friday. Yes, sir, I was struggling. Yes, I realized that a lot of persons were struggling with a nephron, and we're going to revisit the nephron. No need to worry. Trust me. If I say there's no need to worry, there's no need to worry. It is not that difficult. Trust me. It is not that difficult. But what I want you to remember, I want you to remember these before we start talking about the nephron next time. The nephron is also called a kidney tubule. All right? So it's also called a kidney tubule. Now, the parts of the nephron are the Bowman capsule that we represent here. Then we have some loop, that we call the proximal convoluted tubule, or the first convoluted tubule. Then we have this loop that we call the loop of Henle. And then when you go away from the loop of Henle, there is going to be what is called the distal or the second convoluted tubule. And then the second or distal convoluted tubule is connected to the collecting duct. Now follow me. I didn't make mention of the glomerulus, but it is there with the afferent and efferent arteriole. Now, if you don't understand or don't know the parts and you can't follow very quickly the parts of the nephron when I'm explaining or when anybody is explaining it, it's going to cause a little problem, because the person might be going between nephron and kidney tubule, or they might be calling the specific part of the nephron like a proximal convoluted tubule or the distal convoluted tubule or the loop of Henle. And you might, but we were just talking about nephron. What is this distal convoluted tubule? Is it different than the nephron? No, it's just a part of the nephron. So you have to get used to all of those terms. If you are not used to all of those terms, when you come to the lesson, you are going to struggle. All right? So please continue to read, continue to practice. I want all ones in. I want all ones for the exams. Whatever exam you're doing, whether you're doing bio or you are doing HSB. Remember, if you are doing biology, we have all 8 labs for CXC on the channel. You could go to my channel and just click on the playlist that says bio experiment. And if you are not so good with the skills like AI, MMORR, if you're not good with those, you can also click on that playlist that says biology skill, and it will provide you all the guidance that you need to ace your labs. Now, please be reminded, I like to say this and I like to say it very often, to like, share, and subscribe. That is pretty much what fuel what we do here. All right. Remember to spread the word in your community. If you are so driven, feel free to put our advertisement on your WhatsApp status. We'll be very, very grateful for that. Until Friday, take care. Good evening. Uh, to reach me, there is, of course, my email address on the channel. When you go to the channel, when you type in CSEC Biology, the cover page, you'll see this blue icon comes up that says CSEC Biology TCP. You could click on that. It takes you to the back end of the channel where you'll see playlists and all the videos. Go to About, scroll down below that thing there, get down to the bottom of the page, and you'll see View Email Address. Click on View Email Address, and you'll see the email address for the channel. You could just use that email address to send us whatever message you want to send us. All right. All right. Any other questions? I'll take your questions before I go, if you have questions. All right. If there's someone that can ask the email address and post it for the person that I think is Fraser that is asking, you could post the email address. Like that, yes, you could post the email address. Can I get a number? Oh my. Care to say why? Persons can always get a number, but it starts with a conversation via email, as it is not safe for us to give a number online. Uh, but do you care to say why you'd need a number? Where are you? Fraser, where are you? You don't have to tell me. Are you Jamaica, Kingston, Town, another Caribbean island? Where are you? You're in Kingston. Care to say where in Kingston? All right. You don't really have to say it if you're not comfortable saying it, but you could just go to my channel in the back end there, and send me a email, and from there we can have a conversation. But as to give a number online, oh, that's out by east. I am supposed to come by that side and have some town cry doing. Yeah, we're in Kingston. I'm pretty much in Alpha Tree, Kingston. I'm in Alpha Tree, Kingston. So send me an email. And do you have a class? Are you attending a class? Are you a student, as in a student under, what do I say, 16 teenager? Or are you an adult learner? Because that's another thing. If you are a teenager, we need parents' consent to actually work with you, all of that, versus adult learner, that type of a thing. There's a whole lot of regulation that we have to follow. We don't just, oh, you're an adult student. Okay, I see. And you attend an evening class? Do you want to tell me all of this in the chat? You could write me and tell me everything. I don't know you want everybody to know your business. Write me, go to my chat, the back end of my channel, and see if you can get the email address there. And then you can write me. However, we have 3 classes per week free. We have a class on a Wednesday at 5:05. We have one on a Friday at 5:05. We have one on a Sunday at 5:05. And we have several videos on the channel, animation labs, that type of a thing. And for the persons who are going to be doing biology next year, the grade 10 students, we are going to be posting sometime soon a water body, a really polluted water body, something that is fitting for your exam. And we are going to be providing description as much as we can when we visit the location. It's a very dangerous place because we know that there is crocodile in the area, and we know a lot of things. The nutrient content in the water is really, really high. We have leachate coming out in the water, but we're going to try as much as possible to see if we can be safe in sampling that area and uploading the video. All right, so send me a message via email, and from the email, we can take it from there. All right, do we have any other concerns? And students, please be reminded, don't give your telephone number on the live. All right, so if you didn't like or subscribe or share, you can do that now. It's a good time to do that now. The show is finished. If you have to leave, you can go. Thanks much for stopping by.